Okay, welcome back to the MathMinds Project Tuesday math meetings, Tuesday evening, 6 o'clock, every Tuesday during the spring semester until May 4th. Welcome back, folks. We have an awesome group here today. We have representation from Brooklyn College, as always. And also today we have a lot of new students from Baruch College who are joining in on the MathMinds Project. So we're happy to have this awesome group of people. We're going to be talking math, doing math. Remember, there's no grades here, folks. So it doesn't matter if you don't do something correctly or if you do something correctly. You shouldn't feel concerned about whether you're right or wrong in this environment. The idea is to participate and just start building your math literacy through simply participating. So, as you know, every week we have a new math mission, and this week's math mission is titled Deal or No Deal. And that might ring a bell because there was a wonderful game show on TV starting in around 2006 or 7 that was on the air for several years and off the air, I think back on the air. Have you all seen Deal or No Deal with Howie Mandel? I bet you have, right? I bet you've seen at least one episode. All right, so it's just a kitschy title. What we're really talking about is business finance math today. Super exciting to talk about it. And in case you're wondering, well, what is a management professor doing talking about business finance? I actually also have taught finance at different times of my life. I was a finance major in my graduate program, and I also worked for 7 years helping build a private equity firm, basically from the ground up. So my expertise crosses between finance and management. All right. So hope you're doing well. We've already kind of gone through the salutations, and I hope you're ready for some mathletics. You have your pen and paper and your calculator nearby, right? So let's jump into it. But before we do, just want to make sure a couple of things, is housekeeping things. Number one, if you haven't already, we've got a 30-minute math challenge that, in fact, Michelle, maybe you can post that link to the chat board, because the folks from Baruch who are joining today definitely wouldn't know about this. So test your general math skills. Don't worry, this doesn't count towards any grades or anything like that. This is just an opportunity for you to see kind of what you know and what you don't know, and for us to help us with some research we're doing. So take our little 30-minute math challenge. It's just a Google form. It's really easy. Do your best. It's multiple choice. Second, have you subscribed to our YouTube channel? There, we already have actually almost 30 subscribers in just 3 weeks. This YouTube channel has been up for 3 weeks. We're posting there our playlist of these meetings. So if you miss a meeting, you can go back and watch the meeting. So for those of you who are new, you haven't been to our first, we've already got 4 videos up there. You can go back, watch the videos, fast forward through some of the, blah, blah, blah stuff. Just get to the challenges, try the challenges, and then look at the solutions. That's how you want to handle our YouTube videos. And then finally, especially our folks at Baruch, where we don't really have too much traction, we encourage you guys to share our MathMinds promotion, our flyer. We'll be doing this. This is our 5th meeting of the spring. We've got 5 more scheduled, and we're happy to have you guys here. We want more students, right? We can have 100 people on this call, and I'm not shy. I like the more people, the better, right? Bring it on. So we've got almost 20 today. We've got room for 5 times the number. So help us promote. Let your friends know, let your professors know that we're doing these free math workouts on Tuesday evenings. All right, so the math mission today, again, is titled Deal or No Deal, but really, it's really, we're going to be talking about different applications of business finance math, right? In a kind of, it's served to you in a maybe in a different way than your finance professors might serve you this information. Remember, this is not a, these are not courses. This is not a course. So this is kind of like crash course knowledge that you're getting in the MathMinds project. So we don't have lots of time to teach you theory the way that I might if I was your corporate finance professor, but that's okay. You should still feel happy to be here and confident to be here. no matter what your finance skills are, if you're a finance major or not, if you've taken corporate finance or foundations of finance or not, doesn't matter. Do your best. So for some of you, this is going to be review. For others, others of you, you're going to say, oh my God, what is this guy doing? I've never learned any of this stuff. Don't worry about it. Just follow along with us. You're going to learn something. You can go back and watch the videos again and just keep building your knowledge through repetition. Okay. So I won't read through this overview, and we'll just kind of get right into it. You can always go back to the video and read it on your own. By the way, raise your hand in the chat. Raise your hand, your virtual hand, if you worked on today's math mission, even a little bit. Raise your hand virtually in the chat box. Jashoba, awesome. Zach, awesome. Rong Ling, Mila. Oh, Mila, welcome back. I didn't see you before. And Zach, welcome in also. I didn't see you at the beginning. Awesome. So we've got some of you guys already engaged. I'm looking forward to hearing what your answers are to the exercises. Oh, remember guys, also, sorry, Michelle Hess is keeping track of how many questions you all answer and explain correctly, right? And at the end of by May 4th, we're going to tally it up. And whoever has the most correct answers will get some kind of prize. Don't know yet what it is, but trust me, it'll be something fun. Okay. All right, let's jump in. So I will remind you before actually doing the first challenge, a couple of formulas that I think would be useful, especially for those of you who are not taking finance already, or if you don't really remember, right? You remember in our last meeting, we talked about in Show Me the Money, the compounded interest formula looked like this, right? Right. So the future value of some amount of money we can call C0, some money today, multiplied by some interest rate, 1 plus an interest rate raised to T, which is the number of time periods, right? So we did some exercises like this in the last math mission. Well, what if we take that and we substitute, instead of FV, future value, let's call that C sub T. And instead of C sub 0, let's just call that PV, or present value, right? Because C0 is cash today. We can refer to that as present value, and C sub T is cash sometime in the future at time period T. So we can think of that as future value, right? So we can substitute those letters and just kind of rejigger the formula. Then how about we just flip it around? Flip it around, put the left side on the right side and the right side on the left side. And lo and behold, we'll divide both sides by 1 plus r to the t power, and bam, we have what's classically known as the present value formula, right? So this is the very core corporate finance fundamental. The present value of some future cash flow at time t is simply that cash flow at time t divided by 1 plus r raised to the t power. And when we're doing present value rather than future value, we don't refer to it as the r as the interest rate. We refer to it as the discount rate, right? Because instead, we're not going present forward, we're going future back to get to present value. So we refer to r as the discount rate. Okay, so that formula is very important. So why don't y'all keep that hand, write that down so you have it. And let's move into mission challenge 1. So mission challenge 1 is a multiple choice exercise. The money in a savings account increases by 0.6% each month. Which of the following equations show the present value, PV, of the money in the account based on the future value, FV, after a period of M months? Zach has raised his hand. Zach, does that mean you want to answer, or do you have a question? Go ahead, you can unmute.
No, I want to answer.
Oh, you're ready. You're ready to do it. Okay. Okay, go right ahead, man. Go right ahead.
So
explain your answer, though.
So I think it's C, because I know that the present value formula, I'm used to seeing it written as present value equals future value times 1 over 1 plus the rate of return to the power of the number of periods.
Okay, but just note, you're saying the same thing because you said times 1 over, so it doesn't matter. You can also just slip it right under the
Yeah,
future
so
value.
slipping it over, that would be C.
All right. So I would say, Zach, you're getting thrown off by something. It's a very minor thing. You're right on the
Oh,
right track.
the right, B, my bad. The what's it called? The percentage.
Yes, the percentage,
Yeah,
so the percentage is expressed as 0.6%, right?
yeah.
If
I
it
missed.
you missed that little decimal. And that's an
Yeah,
easy thing to miss, people. That's an easy thing to miss, right? If it was C, then the interest or the discount rate would be 6%. So B,
yeah,
on the other hand, is the representative 0.6%, right? Fair
yeah.
enough.
I missed the decimal. My bad.
That's okay. That's okay. So does that make sense, folks? Anybody have any questions on that? That was a little, start us off not too hard. Let me just check the chat box. And Michelle, just stop me if someone says something in the chat box that I should attend to. But we have Yuki answered in the chat box correctly. Great job. And Rongling also corrected on the percentage to decimal. Thank you, guys. Okay. Challenge 1 in the books. Challenge 1 in the books. So, and guys, don't get let me just make this point in case someone is confused. Let me just make a quick point here, actually. Come on, where's my pen? Hey. Um, is this, just bear with me. My tablet seems to not want to be functioning. Just give me a second, folks. Here we go. Okay. So, don't get, so here in the previous slide, right, I showed you that up here was C sub T, okay? Don't get thrown off by that, right? FV is one way sometimes we express the future value of some cash value as FV. We can also express it this way. And by the way, in this case, it wouldn't be C sub T, it would actually be C sub M, right? Because we're dealing with M time periods. Okay. So yeah. So you might see it one way, you might see it the other way. All right. Challenge number 2. Challenge number 2. So you're the CFO of an awesome tech upstart. A product manager has presented an idea that requires one $50,000 investment upfront that she says is sure to return $70,000 exactly 2 years from now. There's no risk, she claims. The only other alternative you have is to keep the money in the company's brokerage account, which you expect will keep earning 12% each year, pretty much risk-free. What do you do? And what are some important points to consider? So let's stop here, give you guys a minute to think about it. You can pause the video, Michelle, for a moment. Think about this, and we'll come back in a minute. Give you a hint here, this is a present value construct, people. Or I guess you can also think of it as a future value comparison. You have there's two ways to do this, and we'll hear from you guys and see what you guys have to say. Zach, hang on. We're going to give someone else a chance to jump in first since you did the last one. Okay. Unless you have a question.
I actually do have a question. So
Okay.
for like for problems like this, are you supposed to assume that the product manager is like competent and like knows what she's doing?
Well, I think that would be a other important point to consider. You can bring that up. It's a realistically, it's a good point. That's why this last question is in the exercise. So for the math, assume that she is, but then that would be something that in reality you'd want to think through.
Okay, cool. Thank you.
Mhm. All right, let's unpause the video if it's paused, Michelle. And let's jump back in. So let me check the chat box. I like this comment in the chat box. Ramatule. Sorry if I'm not saying.
You can call me Rama. You can call me Rama.
Ramo, let's go with that.
Yeah.
You don't trust people who are too sure of themselves, right? That there's no risk involved.
Yes, there's always a risk involved.
Okay, well there you go. So now you and Zach pointed out two important points to consider, right? When someone says there's no risk, yellow flag, right? And then of course someone's competence also plays a role here. But for the sake of the math exercise, we'll assume that there's no risk, and we'll assume that the product manager is competent. Does anybody want to talk this through?
I would still personally choose the second option, the brokerage account, because I made the calculation, and from what I've found, if you invest the 50,000 and you get 12% each year, you get 6,000 per year, which will take approximately 2.5 years ish to get like 70,000 plus. So I think that's probably a safer and better investment to me.
Okay. Well, it sounds like that you're not quite convinced that there's no risk in the 70,000, which is why you're going for that. But let me ask you, Rama. So can you give us an exact number of what the 50,000 will be worth at the end of 2 years invested at 12%? Can you do that calculation and actually tell us the number?
It's 12,000.
Remember, there's compounding though, Rama.
Okay.
If it was simple interest, you'd be correct.
Mm-hmm.
It's actually slightly more than 12,000. So,
Okay.
so let me give you a hint, okay? We just showed the compounded formula earlier. You would want to do the principal, 50,000 times 1.12 raised to the second power. You have a calculator nearby?
Yes, 1 second.
Okay. Someone might have thrown it in the chat. Go ahead, please. Rama?
Oh, sorry. You want me to calculate it?
Yeah, please do.
Okay. So 50,000 multiplied by 0.012.
1.12. Remember the compound interest is 1 plus r raised to the t power. So what we're doing is we're fast forwarding the 50,000 over 2 years, and you're looking at what that would be if compounded annually at 12%. So 1.12 raised to the second power times the 50,000. And what does that give us?
62,720.
Okay, so you see it's a little more than 62,000, 62,720. Thank you. Now let's kind of continue though, because Sahib Jot says that the product manager's rate of return is better. Do you want to explain that to us, what you mean and how you get that? Sahib Jot, can you?
Yeah, actually, how I got that one was like when we do the equation that the present value, I put the present value as 50,000 and the future value to be 70,000. That equation that you gave us, and from that I got the discount rate that we got, and the discount rate that I got was 18.32.
So you took 50,000 as the and the current investment, and the 70,000 that she says you'll get in 2 years from now, and you calculated the value of R to get a present value of 50,000. That's what you did, and you
Yeah, that's
basically
what I got.
you
That's what I
backed into an actual rate of return, and you found a rate of return that is equal to 18 something percent, which is better than 12%. Interesting. Interesting. So let me share with you guys, this might help you. So here is the present value formula that I shared with you a few slides ago, right? I showed you this. So when we think about net present value, right, when we have an upfront investment, all we do in that case is subtract. We show the cash today that you have to invest as a negative number. But actually, what we just talked about, right? What we just talked about by Sahib Jat, he did it a little bit differently than this, actually. What he did, this is interesting. What he did, so is he said, imagine if you bring this over here and you set it equal to 50,000. And here you put 70,000. You could technically then calculate this R with T equal to 2. That's exactly what he just did. That's what he did. Now, what you can also do is calculate what we call net present value. That's the classic way to do this. And the net present value, let's think about it that way. So actually, I'm going to put Sahib Jat on the spot. Sahib Jat, can you explain how you can do the exercise to solve for the net present value with discount rate of 12%? Are you able to do that?
Yeah, 1 minute. So I will use my calculator to do that.
So go ahead. We'll give you a second, a few, half a minute.
Okay.
And the rest of you can try this as well, right? C0 is 50,000, so we have negative 50. And then here we have 70,000 2 years from now. So we have R is 0.12 and the T value is 2. And you're going to get some number from that. You can all try that on your own. If you're following along, try to work the math out also. Toshiba has an answer, but we'll wait for Sahib Jat to give me his. I think, Toshiba, I think you're right. Let's see what Sahib Jat gets. Sahib Jat, do you have an answer?
Yeah, the answer that I'm getting is 5,835 and 0.71.
So yeah, so if you look in the chat box, Toshiba got something very similar to that. So probably you guys are both doing it correctly. Let me share with you. Let me share with you the calculations. I think I have on the slide here the calculations. So you can set this up as an NPV exercise, as I mentioned, with C0, which is today. You make a $50,000 investment, so you use negative 50,000 for the investment, and then a positive cash flow at C2, which is a 2 years from now of 70,000. Since both of these are risk-free, at least they're supposed to be. So, and our only other alternative is to keep the money in the brokerage account. That's why in this case, it's rational or reasonable to use 12% as our discount rate. That's the whole point of a discount rate. It's typically at the same risk profile. What's our alternative? That's the way many, let's say, CFOs or corporate finance folks think about doing NPV, okay? So we use that as our discount rate R and T as 2. And when we do that, we end up getting this math. So Jashiba was spot on. And I think that was what the number that you were coming to as well, 5803.57. And in general, folks, as a little review for you, in net present value, if the NPV is positive, then from a mathematical perspective, it says we would invest that the project or an NPV positive project is one that from a mathematical perspective, we would invest in that, okay? And generally speaking, positive NPV, you take a project. Negative NPV, you reject a project. And if the NPV is near 0, you are mathematically indifferent, okay? However, that being said, I think that there were some good comments made from a practical perspective by both Zachary and by Rama, okay? Zach said, hey, is that product manager really competent, right? And Rama was like a little kind of skittish with the thing is risk-free, right? So Rama thought, I'm going to take that 12% and because I know I'm going to end up with 62,000 and change. I don't believe that this is really risk-free. That's a very rational decision point that you made. Because if you don't believe it's risk-free, then in fact, technically, mathematically, what you would do there, by the way, Rama, is you would use a discount rate that is higher. You would, what discount rate? I can't really say to you right now, okay? But you would increase your discount rate to deal with the fact that you believe the risk is higher in this particular project. Okay, and that's the way. Higher risk, we typically use a higher discount rate. Lower risk, we use a lower discount rate, and that is in practice the way finance professionals actually do this stuff. Okay. Any other comments you guys want to have? Any other thoughts about this exercise on how other things to consider here? Anybody else want to share? Okay, that's fine. We can move on. So let's do that. Challenge 3. Challenge 3. You are choosing between 2 projects with the following cash flow projections, right? So both of them have a investment or a negative cash flow or an outflow of $1,100 presently at time 0. And then they have different profiles for 1 year, 2 year, and 3 years out, which are here shown as time 1, time 2, and time 3. As you can see, the sum of the cash across the 3 years is, well, it's different actually, right? It's $1,400 for the first project and $1,800 for the second project. But you'll notice that in the second project, the bulk of the money comes 3 years from now. And in the first project, the majority of the money comes pretty much right away after 1 year, which changes things. Assuming your discount rate is 12%, which project do you choose and why? So take a minute, solve the NPV for both, and we'll take volunteers for your answer. Let's pause here. So you guys should be setting up NPVs for each of these projects. All right, we'll take a volunteer now. Anyone want to volunteer to walk us through? Joshiba. All right, talk us through. How you doing this?
Okay, so for project one, well, the formula that I used was what you just mentioned, was the MPV. So the initial investment minus the sum of all the cash flows divided by 1 plus I to the power n. So I did for time 0, just subtracted 1, well, it's a negative is a cash flow. So 1,100 plus 1,000 over 1 plus 0.112. And for time 1, the present value was 892.85 cents.
Okay.
For time 2, year 2, discounted it back. I got 279.
Wait, how did you do it though? Like, give me the.
Yes. Yeah.
Give me
So
the.
okay. All right. Yeah. So it was 1.12 to the second power, and that equaled 1.2544.
Okay, so it looks like what I have on the screen here, 350 over 1.12 to the second power.
Yes.
Great. And what does that come out to be? About, just give me the round it off to the nearest dollar.
All right. So 280.
Okay.
So then I did plus 50 to the 1.12 to the third for year 3.
Great. And what does that come out to rounded off?
36.
All right, let's just pause here. You all see that, people? We're doing the first project, or Joshiba's doing the first project, and he's correctly taking each of the cash flows and he's correctly dealing with them separately because they happen in different time periods and discounting them appropriately. And then what does this all sum to?
$108.
Okay. And did you get to the second one as well or not?
Yes.
You did. All right. So so the second one's done exactly the same way. So just tell me the NPV for the second one.
207.
Great. Okay. So, and by the way, I'm just fast forwarding, but I'm sure what Joshiba did was take 11 minus 1100 plus 0 in time 1 plus 300 divided by 1.12 raised to the second power plus 1500 divided by 1.12 raised to the third power. He added it up and came to this number. So we have 2 projects with 2 different NPVs. Which one looks better?
Project 2.
Exactly, project 2. Excellent. So thank you, Joshiba. Let's just walk you through. So the formula, more written out here on the screen, just so that you all see, for those of you who may not remember or haven't learned this yet, okay? So when you have multiple cash flow, like in the past exercise, there was only one cash flow in time period 2. But in reality, projects will have multiple cash flows. It could have a cash flow at year 1, year 2, year 3, blah, 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 all the way to whatever, right? If it's a project financing, like a mining expedition, it could have a 20-year life. So, you have you have to do the NPV calculation separately for each of the time periods, right? What you do not do, you do not add up the cash flows and divide by 1 plus R to some power. You do not do it that way. People make that mistake often. You have to separate your discount calculations accordingly. And you can also write the formula more compactly like this, where all this says is this, it's the same as above, but it's just taking the sum, right? Sigma, the sum of this model with I ranging from time period 1 to time period capital T, which is the latest time period. So if you have 10 years, T is 10. If you have 5 years, T is 5. If you have 20 years, T is 20, right? Whatever it is. Okay. So that's the classic formula. So Jashiba did it correctly, but we do have the calculations here for you on the page. So here it is. Go ahead and pause when you watch the video and take a look at the details, but you can see his numbers were right, and his numbers for the second project were also right. And correctly, he went with project 2 because it has the greater NPV. Excellent. Love it. What do you guys think? Any questions on this? Any questions at all? All right, no questions. Let's move on to challenge number 4. Challenge number 4. Challenge number 4, something different again. And if you joined us in MathMinds in the fall, then we did this exercise back in like October or November. But that's okay. We'll do it again. So you're considering a project with the following cash flows: a 700 million outflow presently at time 0, a $200 million inflow after 1 year, and an $800 million inflow after 2 years. Now, this is a little different exercise because what we're asking for here is the project IRR, which is the internal rate of return. Don't worry, if you don't know what IRR is, I'm going to explain it momentarily. But if you do, you can, hopefully you've tried the exercise, or you can try now. Okay, if you have a financial calculator, actually financial calculators have IRR built in. You can use it. You can also use Excel, by the way, as a hint. But you can also do this by guessing and checking. Now, there's no time now to do it by guessing and checking, but maybe some of you did it that way. So let's pause for 30 to 60 seconds. And meanwhile, we'll take a volunteer, maybe someone besides someone who hasn't spoken yet. We'll give you a chance to jump in here. You can raise your hand, but let's pause for just a minute and then come back. All right. Has anybody broken out their financial calculator or worked this out by hand in any way? Anybody who, obviously you have to know what IRR is. Anybody want to jump in with a explanation? I'd love for someone who hasn't spoken to tell the MathMinds group what IRR is. Can anybody do that in your own words? Who's this?
Yeah, so I don't know exactly what it's used for, but I know what it stands for.
Okay, what does it stand for?
Internal rate of return.
Yes. Okay. So use your intuition, Zach. What do you think it might be?
I mean, maybe it's on like project analysis or like
It is.
budgeting. Maybe like it's like about like if we invest this much in a project that we're doing, how much money are we going to get over the years? Like how profitable is it
Yeah,
going to be?
it's the return. It's a tool or a metric used to. You're right. It's a metric that's used to define the return of a particular project, which requires a cash outlay up front with expected cash returns in the future. It's exactly what it is. Internal. Internal doesn't mean like inside. Internal means for the project, rate of return. So it's the project's return, annualized. Right. Because, and use, as you saw with net present value, we use a discount rate and then we calculate a net present value, which is either positive, negative, or zero, right? So internal rate of return doesn't use a discount rate. It just tells us the return of the project. That's what it does. Now, Zach, since you volunteered yourself, do you recall how we do it?
So I looked up the formula for this, and my calculator is not capable of doing it, and I didn't even know where to begin. So, yeah. What I mean, like I know what I would usually do here, like, is go to one of those like calculators online that'll do it for you.
That's
You know,
fine. Yep.
yeah. But which I did for this.
Okay. What'd you get?
Rounding to the nearest percent, it was 22%.
Oh, and you're right.
Yeah, it was specifically 22.128%.
Look at that. And see, folks, you there are resources available to you all over the place. Zach went out, found a resource, got his number. And you know what? That's the right number. Now, did anybody else do this exercise using their calculator or in some other method you want to share? Anybody else?
I saw another method online. I did not try it yet, but basically they kind of said to find what would equal NPV to 0%.
Yes. Who's this?
Rama?
Rama. Yes, it's not 0%, by the way. It's
Not
$0.
Oh, okay.
But you're right. You're exactly right. You're exactly right. And that is it. See, you have all the knowledge you need. Now you could set up so what would you do? What can you do, Rama? You need NPV. You're looking for when NPV is 0. You know your cash flows. So what might you do? Let's put the financial calculator aside. Let's talk math. What might you do to actually
Use the formula?
go ahead, say again?
Use the formula for NPV?
Okay, but the formula for NPV requires an R value, right?
Right.
So how do we do it? We don't know the R value. What do you think? Just think practically. Just think practically. What do you think? Don't overthink it. Rama, let me ask you a question. Did you ever watch The Price is Right?
No, I don't think so.
Yeah, I'm too old for that conversation with you. Darn it. I would have had a great analogy for you on The Price is Right, but I can't think of one that's more relevant to today. What do you think we might do? I see something in the chat box. Let's see if someone has something to say here. We guess it. Sahib Jot says we guess it. Exactly. Exactly. We guess it. So Rama, you know how to set this up as an NPV, right? We did it in the previous 2 challenges. So you take one thing you could do is you could guess an R. Just pick an R value, 20%, 10%, whatever you want. Pick a number, right? Pick a value.
It's going to work regardless?
I'm sorry?
I said, is it going to work regardless of the number?
Well, that's what you're about to find out. Sometimes, and let me give you a little math lesson here. Sometimes with math, the answer comes out of experimentation. You can't always get frozen, or don't allow yourself to be frozen when you don't know a specific formula. I see this too often with people, and many times on aptitude tests, you're purposely given kind of abstract questions where you don't know what to do. And the only way to answer the question is to simply start experimenting. So in this case, we're going to experiment. Now, we don't have time right now to experiment because it will take you some time. But what I have something built on the slide to show you what we're going to do. Okay, so Rama, pay attention carefully now. Okay, so we would be experimenting, or as was said, we would guess. Okay, so as you pointed out, though, the IRR is simply equivalent to the discount rate that makes your project have NPV equal to 0. IRR is probably a bigger metric used in business than NPV. Like when management people talk about projects, they simply throw things out. What's the IRR of the project? That people they feel comfortable with IRR. Just kind of they understand. And many companies, they have like a required hurdle rate, that an IRR hurdle rate a project has to have in order to accept it. And the company decides what that hurdle rate is, 18%, 12%, 25%, whatever it is. That's company specific. So how you do this, you can guess and check. Now it takes time to guess and check, okay? It obviously is not the most efficient way to do this. The second method is financial calculators have a function where you can put in the cash flows and it will calculate IRR for you. But even better than that, people, you can use Excel. And we're going to be talking more about Excel next week, but a little bit today, okay? But Excel has a great IRR function. It's so simple. You just put in the cash flows into the cells, you type in IRR, open paren, and then your cell string, close paren, and boom, it calculates it for you. So let me just kind of show you step by step. Here are the cash flows. Again, here's the exercise. We're gonna guess and check first. So let's say you randomly tried to solve for NPV with R equal to 15%, okay? You would get a positive NPV, That means that the R we chose was too low. Because remember, with NPV, bigger R's make our NPV value smaller, right? So we need to bring up the R value in order to bring down the NPV. Right now it's positive 78 million. So let's say we tried 25%. You do it again, you do the math with 25%, and now you get negative 28%, negative 28 million as your NPV. Now that means it's too high. You went too far. You went too far the other way. 25% is simply too high of an R. You want that, remember, we want that NPV to be 0. So we go somewhere in between. We try 20. Now at 20%, our IRR is now lower than 15%, but still not 0. It's 22 million or 22.2 million. And if you continue down this path, you would see that at 22%, you would have an IRR, an NPV of 1.4 million. So you can see we're moving in the right direction. And in reality, using this guess and check method, our IRR is definitely between 22 and 23%, somewhere right in there. And of course, you can keep doing this. You can try 22.1, 22.2, 22.3. Obviously, that's not very time efficient, but it's a good exercise to learn how IRR works with respect to NPV. And as I said, you can also simply in Excel put in your cash flows like you see here. This is just a screenshot from Excel. And if you have these three cash flows, you can enter into Excel IRR, and this was in column C to column E. Of course, it depends on where you put your numbers. And boom, outcomes 22.14%. Or you can do what Zach did, go to some website that calculates IRR for you, or use a financial calculator. Okay. So what the moral of the story here is, many things actually. Know what IRR is, right? It's the internal rate of return of a project. Know why we use it, right? It's a fast way, it's a fast metric to decide, to see what the return of project is. And managers typically like to talk that way. They just want to know what the IRR is, and then they go from there, okay? How you calculate it, you can do guess and check to see where your NPV is 0 and keep changing the R values, or more rapidly, use Excel or a financial calculator. All right. I hope that was a nice, quick and dirty review of IRR. I realize we're moving very quickly here. Any questions from you guys? Sorry, Jashiba, I didn't give you a chance to jump in there. I know you had your hand up at some point.
That's all right. Yeah.
And Yanmin is, oh, Yanmin is showing us some math where, yeah, you've got your 700 we know is your cash outlay, and you could work this algebra, Yanmin. Yeah, you could. You could. And you could solve for R that way. You could absolutely turn it into an algebra exercise like that. Absolutely. So I like that. Yanmin is showing you in the chat box how you can use algebra to solve this as well. And why that works, because what she's doing is, rather than having negative 700 in there on the left side equal to 0, she simply moved the negative 700 to the other side and set it equal to the other discounted positive cash flow. So nice job. Yuki, I'm not sure what your comment was meant to say, but if you wanted to write, did you want to add something, Yuki? No? Okay. Okay. Oh, Yuki was saying that you did it the same way Yanmin did it. Excellent. Good, guys. No problem. Definitely the algebra is more, is a more, how shall I say? It's definitely more exact than guessing and checking. No doubt about it. So we can use algebra. We can do guess and check. We can use a financial calculator. We can use Excel. We can use a website online. Many ways to get to the IRR calculation. Cool. I like that. Multiple solutions. All right. Challenge number 5. This one is a little harder, and we're not going to be able to do this right now. I'm hoping someone tried this, because we're not going to have time. You're not going to have time to actually work this out right now. Let me read through the exercise and then see if any volunteers want to talk through their explanation. So you're considering a $20,000 financing loan to buy a new car for the company. The interest rate on the loan is 18% per year, compounded monthly. Minimum payments on the loan is $350 per month. Part A, if you just make the minimum payments, how many months will it take you to pay off the loan? And in part B, if you increase your payments to $700 a month, how long will it take now? And is there anything eye-opening about this exercise? And I'm not going to read the bottom part. It just kind of gives you some directions on how to work this out. But the key here, folks, is you can only do this by running through an amortization table, which is a very typical thing we would do in finance as well. And this is something you'd want to do if you were taking out a loan, even personally, some big item you're buying. You could be, taking a loan out for school, taking a loan to buy a house, taking a loan to buy a car, like on the exercise, right? So did any of you raise your hand if you worked this exercise out? Who worked it out? Anybody? Yan Min worked it out. Yan Min, you haven't spoken today. You want to talk? I know that it's like going to be hard to show us. You want to kind of talk through what you did and what you ended up with for part A?
Actually, I took a personal finance class before, and then the professor gave us app on the phone. Is the name is EV calculators.
Oh, nice.
Yeah.
Can you type that into the chat box? Can you type that into the chat
sure.
box? Type it in. Okay, so you used an app. That's fine. Let the app do the math for you. No problem. So you want to tell us how many months now? You know, it's possible that the calculation was done a little bit different from what I did, but I imagine we won't be far off in our answers. How many months did it take to pay off the loan if you make minimum payments? Yeah, of 350.
It's 125 months.
That is a long time, isn't it? What does that come out to in years?
In years, more than 10 years.
More than 10 years. Oh my God. Do you want to be paying off $20,000 for more than 10 years? No. Right? I think the answer is no. So,
No.
yeah. So, okay. So Yanmin got 10 and a half years, roughly. Doesn't matter. 10 years, 11 years. We have an idea. Okay. Now, what happens now? Did you try part B? Up your payments to 700 a month?
Yes.
Okay. So when you up your payment to 700 per month, now how long does it take?
It takes 37 months.
Oh my goodness. And that's how many years?
More than 3 years.
3 years and 1 month. So, people, the moral here. Now we'll go through, I'll show you how I did it. It doesn't, let's just step away from the math for a second. Listen to the difference here. If you make the minimum payment of 350, it would take you 10 and a half years to pay the loan off. If you up your payments to 700 a month, all of a sudden you pay it off in 3 years. Think about that. Just increasing your from the minimum payment, not substantially, right? Not coming off the minimum payment decreases your long-term exposure dramatically, dramatically. Thank you, Yanmin. Let me show you kind of how I went through this, by the way. So this is just a screenshot of my Excel, okay? So I did it manually, and let me just check the chat box. There's some, Easy Calculators, the app. Great. So I just made my own amortization table in Excel. And by the way, next math mission for next week, you're going to be doing some Excel, and I'm going to ask you to do your own amortization table for next week. But here is just an example of what I did, right? I have a column to my column B is my running balance at the beginning of a period. My column C are my payments each period. Now you can see on top in cell B1 is where my starting point is. I have this set up where 350 in C1 is my payment each month, except for first month. I set this up where you don't pay in the first month, but you accrue interest. And then cell E1 is my annual interest, okay? So each month and each row starting from 3 is a month. So we have month 1. So I'm showing you here just month 1, 2, and 3, and 4. Let me just get my pen. Hang on, just give me a second. So you can see here, for example, I'm showing you how the formula works where I'm calculating this cell here, okay, which is just take my beginning balance, subtract any payment I made that month, and multiply that by the annual interest rate divided by 12. And that calculates the interest that I'm accruing in that month. And then my ending balance for that month is just the beginning balance minus what I pay plus new interest. And that gives that to me, right? So for example, we can look in this row, okay, where we started here. We would subtract off the payment. We would add the interest, and we would end there. And you see the reason why it takes so long at minimum payment is because our interest, our monthly interest, ends up being not much less than the minimum payment. Okay. And that's where you have to be careful with personal finance, people. You never want to get caught out in a situation where your minimum payment only covers the interest and you don't pay that principal down. So let me just show you how crazy this looks. Look at this. This is how crazy it looks to pay off $20,000, making minimum payments of $350 with 18% annual interest. Now, I don't know why my calculations are a little bit different from Yanmin's, but I got 132 months. She got 125 months. Doesn't matter. We both got a big number. Okay, so there's some a little bit different in the calculation. But really what's important here is we want to illustrate to you what happens when you only pay minimum payments that barely covers that covers the interest and not much of the principal. This is what happens to you, okay? On the other hand, if you make $700 payments, look at how the math looks now. You much less work, right? In my calculation, I got 39 months. I think Yanmin got 37 months. Okay, so it's very close. But the point is that in just over 3 years, you're done. You're done. Okay, this is something that people don't really understand, and why many of us get caught up with massive credit card debt and other types of debt because we take money out, or we take credit that we can't afford to pay back. And when you're making minimum payments, that's when you get screwed. See here, we're making these $700 payments. So look how quickly our monthly interest goes down very fast, and we're much more rapidly paying money towards principal. And that's why you see these numbers decreasing at the rate that they are. Remember, 3 years versus almost 11 years, just by making a little bit more payment off of the minimum payment in an exercise like this. That should be pretty eye-opening for you. Any comments or questions? Anybody else get this done besides Yanmin?
Yes. Yeah, I did another way, like doing mathly, but I got 130 in the first one and then 38 in the second one.
All right. That's Lin King. Who is this?
Yes.
Lin
Yeah.
King. Oh, all right. So Lin King got 130. I got 132. As long as we're in the same ballpark. We're in the same ballpark. We're in the same. So you did it right as well, Lin King. So, it's very, because of the way you do the amortization, the timing could impact how the months actually work. Someone could also be rounding. Someone else might not be rounding, right? So that could vary it a little bit, but the moral of the story is the same. Great. Thank you, Lin King. All right. I think we're at the last math mission for the day. Challenge number 6. Now, this is one you rarely, if ever, see in a traditional finance class, in a corporate finance class. I've never seen anybody talk about this topic. This is a topic that I'm familiar with only because I spent a lot of time working with startups on trying to pitch themselves for financing with investors and stuff like that, right? I've worked with a lot of early stage companies when I was in Poland. And there's something people talk about as pre-money valuation and post-money valuation. Now, did anybody look this up when you saw this mission, this challenge? Did anybody look up pre-money versus post-money valuation? Mila did. All right, Mila, tell us what you saw, what you learned.
I guess it's about like before you have an IPO or shares or investment.
Okay, but be careful. You're right. Pre-money is before, but let's not only talk about it with respect to IPO, right? IPO is one type of external financing, but you could talk about pre-money valuation, but that would be typically pre-IPO valuation. But yes, that's also pre-money, but more generally, Mila, it's pre whatever external financing you're doing, right? IPO is just one way to bring in external financing. You can also more practically, for an early stage company, just get one investor, like in this exercise. But pre-money is the valuation before the investor invests the money, correct? And post-money is after. Now, Mila, since you raised your hand, did you come up with an answer to, well, let me read the exercise to you guys. Your company's doing fantastic and you've attracted the interest of a new investor. The investor wants to make a $500,000 investment into your business in return for a 25% ownership stake post money. What is the implied pre-money valuation of the company? If you've never heard this term, blah, 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 look it up, okay? And I tried to explain what it was here. And then there's a part B. What are some consideration points to determine if this was a good deal or a bad deal? So, Mila, did you come up with an answer for part A?
Okay.
Sorry, go ahead.
I have the answer. Okay, I kind of just used arbitrary, like 1 million, and
Sorry, you came up with what?
I came up with like arbitrary numbers. So
Okay.
like if current value of the 1,000 shares is 1 million, so $1,000 per share.
Oh, I don't think we had anything about the number of shares in here, were there? Oh, I see. You just made up a number of shares, but let's not worry about shares. Well,
Okay.
don't worry about shares. Just what is the? Well, let me ask you another question first. What is the post money valuation? How can you calculate the post money valuation given the offer by the investor? What is his or her or they's post money valuation if they want 25% ownership after their $500,000 investment? What do you think?
I'm not sure I did it correctly then.
Okay, but what
I created shares, and then I
okay.
used the $500,000 investment.
Okay, so well, let me ask you, did you come to what answer did you get? Is it, so your answer is on a per share basis?
Right, per share.
Okay, so what did you get? And you're saying there's 1,000 shares, right?
Right.
Okay,
So
so what is your share price?
Pre-money, 1,000 shares at 1,000 each. Post money, investors have 25%, so we'll issue 333.33 shares to bring each share to 1,125.
Okay. So I think that's a little bit off, but you're going in a good direction. But I think that's a little bit off. A little bit
Okay.
off. So let's see if anybody else. Rama has her hand raised. You want to jump in here?
Just before I get into it, does it have to do with the 75%?
Well, in a way. I mean, in a way, the 75%. In a way, I can't say it better than that. But clearly, it's very. Let's don't make these things overly complicated, folks. Someone said they want a quarter of your business, okay, for their $500,000. So what does it imply the value of the company is? Keep it simple. Keep it simple. Take a guess. You know what? If you don't know what to do, just take a guess. What do you just give, if someone's investing 500,000 into your company, they don't want the whole company, right? So clearly it's worth more than 500,000. They don't want half. If it was for half the company, if they wanted half the company, what would be the implied valuation there? Wouldn't it be just $1 million?
Yeah.
Right. Yeah. So Yanmin has the right math here in the chat box. Yanmin has the right math. 500,000 in this case times 4, okay? Because what we do very simply to get the post-money valuation is set up a very simple algebraic equation, okay? It's very simple. 500, I'm going to leave it in thousands. 500 is 25% of something. And that something is the post-money valuation, right? Because it's after the 25%, and the 500 was all meant to be post-money. It said it in the exercise, okay? So of means multiply in math, right? So we end up with 500 equals a quarter X. And as Yanmin said, 500 times 4. Boom. Lin King, yes.
Yeah, I don't make mistakes.
I'm sorry? Oh, you did it by mistake. So the answer is, people, the post-money valuation is $2 million. That's the implied post-money valuation by having this investor say they want 25% for 500,000. Okay? That implies a $2 million post-money valuation. So guess what the pre-money valuation is? It's just that number minus the investment. And that's easy, right? 2 million minus 500,000.
1.5 million.
Correct. 1.5 million. Okay, guys. So that's it. It's not that hard. Here's the math on the slide. Here's the math on the slide. So that's how you do post-money valuation. And then pre-money would just be pre the investment, right? Post-money, extract the investment, you get pre-money. And we're done. Easy peasy. 1,500,000. So now comes the fun part. It sounds kind of arbitrary, right? Sometimes with math, you can't just take math for math's sake. You also have to kind of, put some practicality around it all. How do we know if this is a good deal? How do we know? What are some of the consideration points that we want to think about? This is up for discussion now. What are some of the consideration points?
Well,
go ahead. Who's this?
Yeah,
Zach.
Zach. Yeah, hi. Well, I think one would be like, how big do you think your company's gonna grow? Because so, for example, right? Like, let's say I'm Steve Jobs and I'm founding Apple and someone says like, I'm going to own 25% of your company, and then it's 2005 and Apple's worth like an insane amount of money, but 25% of that isn't yours. You know what I mean? So it's like it's like giving up 25%. That's a pretty substantial chunk.
It is. It is. So let's just kind of massage that a little bit. You're saying, hey, you're the founder. You think that this thing is going to grow like, like Amazon from 1998, right?
Yeah.
So what does that translate to? It translates to you saying that investor is not giving you enough credit for where you think this company's growth potential is. Fair point. Fair point. Okay, it's one. What's another one? It's another one. How else can we think about this? That's one way. Someone jump in. Let's get some conversation going.
Another one might be. So I'm stealing this idea from Shark Tank a little bit, but
Okay.
The idea of expertise, right? Like, is the person who's buying up 25% of my company, are they like smart? Like,
Good.
will they help it grow more? What do they add?
Good. Perfect. What does the investor bring to the table besides the money? Or do they bring anything to the table besides the money? Very good. Very good. And that's good. Steal from Shark Tank. That's a good place to learn about this stuff. Anything else? Any other ideas, people?
This is Mila. I guess when you have another owner, you have to be willing to give them some of the control for management decisions or ownership.
Good. Yes. Mila says, it's not only about the money, it's also about like, is this person going to are they going to hand shackle you from making decisions? Are they going to tell you when you can and can't take in a new investor, or when you can and can't make an investment into a new project, right? What kind of control does that investor want, if any? Are they going to be active? Are they going to be passive, right? Very, very important. Very important.
But if they own only 25%, do they really have that authority to kind of tell you what to do?
Okay. I like that question. Anybody have a sense of what's the answer? Anybody know?
I feel like since it's not a partnership, since it's not 50-50, like he shouldn't really have as much authority over what you can and cannot do.
Good. So make sure you tell that to the investor when you're in that situation. I think that's a very fair thing to say. But here's what the investor might say to you. Well, I'm sorry, but the only way I'm going to invest this $500,000 into your company, given you're so young and not that experienced, is I want to make sure that you're spending money wisely. So in the investment contract, even though I don't have 50%, in the investment contract is going to say, if you want to make a greater than $50,000 investment, I have to okay it. If you want to bring in another investor, I have to okay it. If you want to take out a bank loan, I have to okay it. So where it comes is it doesn't come from the fact that they don't have 50%. Obviously, if they had 50%, it would be a whole different story. What they do, and this is real, people, I'm not making this up. This happens. Okay. I work with venture capital. Okay. Venture capitalists don't come in, they don't take a majority position, but what they do is put certain restrictions on what you can do written into the investment agreement. That's the way they do it. And that's very common for a venture capital investor to do. So that's how they do it. All right. I like it.
So would you say it depends on the person's expertise? Like how much do they know about their stuff?
Yeah, exactly.
Like,
yeah. Well, for example, Let's say you were on Shark Tank and you got one of those sharks to invest in your business, but you know that person has a lot of experience in that area. You know that. In that situation, you might be willing to sign an agreement where you are restricted in the decisions that you can make because you think that they know what they're talking about. In fact, they probably know more than you do, right? But on the other hand, if you get someone who doesn't have that knowledge, who doesn't bring that type of expertise, and they want that power and that control, that doesn't make sense. Why would you give the power to someone who you don't actually feel can actually help you in that strategic way? You see? So it really depends on who the investor is. So yes. I like this discussion. This is, by the way, my bread and butter stuff. I really enjoy talking about these things. So what I've done for you is given you a slide of several consideration points, and we've talked about some of the most important ones. Okay. So number 2, Zach brought that up. Number 3, it's kind of the same thing. Zach brought that up. Which is also related to number 4. So 2, 3, and 4 are very similar. And then number 5, Mila brought up, right? Decision-making power. 6, we didn't talk about, but it's another type of control that I'm not going to get into right now, but there are other things, other conditions an investor could bring in, like right of first refusal. But again, I'm not going to get into that right now. A couple of other ones we didn't mention. Does your investor have an exit timeline, right? So some with an early, it's not only about the money, but you want to know, is that investor like going to stick with you for many years to come, or are they going to want to exit and flip their investment like really quickly, right? That's an important criteria. We didn't talk about number 1. How does this valuation compare to other companies like yours, right? So you do that kind of comparable valuation. And then finally, number 8, and this is really important. Who's behind the capital? It's not, someone approaches you from some venture fund, like where's the money coming from? Is it coming from family trust? Is it coming from individual investors? Is it coming from some big pension funds? That also plays a role into kind of like what you can expect. So the point is, people, it's not just about the math. The math's important, but you have to understand more contextually whether a deal is a good deal or a bad deal. And there are many factors to consider in making that decision. So that was a little entree for you into some kind of venture capital financing discussion. That was fun. Woo! All right. It is 7:35 and we are just about done. So I hope that you guys enjoyed the mission today, deal or no deal. And the moral of this, people, always don't forget to balance risk with return, right? You want to know how to do this kind of math, but you also want to be able to keep the math in context. Very, very, very important. Now, previewing next week's mission, we're calling next week's mission Analyze This. Now, for those of you who never heard of Analyze This, the movie, check it out. I think it came out like in 1999-ish. Great movie with Robert De Niro. Definitely worth seeing. But what are we really going to talk about? We're going to talk about Excel, which is a very, very, very important application that y'all kind of get yourself familiar with if you're not already. So what we'll do is put out a mission, hopefully by tomorrow, where we give you little exercises to do in Excel, and you come to next Tuesday's meeting with the exercises completed. We will give you an opportunity to try working with certain functions and formulas like if-then statements, VLOOKUP tables, sorting and ranking, and possibly even pivot tables, which are very popular. Okay. So if you want to kind of brush up your Excel skills, you definitely want to participate this week and in next Tuesday's session. Woo! All right. Well, I'll take any questions, but we're done for today. Do y'all have any questions that you want to, or comments or questions from you guys? Any at all? Well, I'm very happy to have some folks from Baruch join us today. And thank you for our regulars from Brooklyn College for participating, as of course, as well as the MathMinds team. I saw Ileana's on, and Zach, and Lynn King and Michelle. Thank you guys as always for participating and being here. We'll see you guys next Tuesday, same bat time, same bat channel. So have a great week, people. Take care.
Bye.